All right, everyone. Welcome back to the Land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again. All right, everyone, welcome back. This is episode 75, and in today's video, I will be revealing the results from a chemical analysis of samples taken by the Isida Project from the iron oxide deposit surrounding the Central Pyramid of Giza back in 2010. This is yet another example of the prolific research that was conducted by the Isida Project over their several expeditions to Egypt, and I will put a link to the full article in the video description below. It is in Russian, but you can use Google Translate to fully translate the page when you pull it up, and thank you so much once again to the Isida Project for giving me exclusive access to this research and for trusting me with the material. Secondly, ladies and gentlemen, I will be doing a very special episode and announcement coming up in the next video. And I apologize for keeping you all in suspense, but trust me, there is a method to the madness and it will be worth the wait. So if you haven't already, now is the perfect time to subscribe to the Land of Chem here on YouTube and click that little notification button because you do not want to miss what I have coming up here on this channel over the next couple of weeks. If you want to help support, just go to thelandofchem.com. You can pick up a limited first edition print copy of the book, grab yourself some merch. Either way, all the orders mean the world to me. Thank you all so much for the support. If you want to follow me on Instagram, my handle is @thelandofchem. Ladies and gentlemen, I think that is it for today's intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. And the following samples were taken by the Isida Project back in 2010, 7 years before my first trip to Egypt. And now I am overwhelmingly grateful to be able to bring this information to light because as with the chemical analysis of the Red Pyramid staining, this research has never before been presented to the public in this format. So before we dig into the huge veins of iron oxide that stretch across the Giza Plateau, let's take a look at a control sample taken from way out here, almost 1 kilometer away from the pyramids. And this is what the material looked like first. Definitely some interesting pieces here. And then broken down for microscopic analysis. And in their paper, this material is described as quartz calcite gypsum mixture with rare brown inclusions, iron oxides, and organics. So basically sand and a small amount of iron oxide, which is exactly what you can see here in the macro analysis, which has the carbon and oxygen removed, leaving very small percentages of aluminum 2.6%, calcium 15.8%, iron 3.4%, potassium 3%, magnesium 2.9%, sodium 0.7%, sulfur 0.6%, and silicon 12.3%. All very normal stuff, and a bunch of trace elements down here, all in too small of concentrations to be relevant at this point. But as always, the control sample is used for comparison, which we will get to at the end. Next up, the scanning analytic electron microscopy. And remember that this is an instrument used to examine tiny microscopic particles and determine their composition. So this first one is described as a small grain of phosphorite enriched with rare elements, typical of precipitation. The analysis is dirty and captures the matrix, meaning this microscopic grain is embedded within the surrounding material and is naturally occurring. But it does have the phosphorus here and those rare earth metals, lanthanum 3.67%, cerium 7.54%, and neodymium 3%. Next up, another grain of barite here with 16.82% barium. Here, a larger and more pure grain of barite with 48.12% barium. And I absolutely love these SEM images, as I mentioned before with the analysis of the metal saw blades. I think it is so cool to be able to simultaneously see microscopic traces of the ancient past while also obtaining their chemical composition. Next up, a grain of chromite, 14% chromium and 34% iron. Here is some iron oxide crust on a grain of sand, 71% iron. And here is a grain of galena, lead sulfide, which I discussed in the previous episode, is a very prominent and typical ore mineral found all across Egypt, 5.6% lead, 9.55% sulfur, and the rest is the background matrix. And last up in the control sample, a grain of magnetite with some titanium at 9.71%. Very interesting, but also very normal. Once again, providing us with a basis for comparison and evaluation of what you are going to see next. All right, everyone, just a quick reminder that if you want to help support the channel, just check out thelandofchem.com. I have brand new merch. There's a new black on black 5th degree logo, hoodies, long sleeve shirts, t-shirts in both logos in a variety of different colors, and of course, the genesis for the entire Land of Chem YouTube channel, my book, The Land of Chem, an initiation into ancient chemistry through the degrees of the Egyptian pyramids. So if you want to help support the channel, just check out the website, thelandofchem.com. You can pick up a limited first edition print copy of the book, grab some merch. Either way, all of the orders mean the world to me. So thank you all so much for your support. All right, now let's dive into the analysis of the iron oxide deposits that were taken from here, 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 and here, and these other two ruts here at number 1 and here at number 2 are the proposed location of two other ruts based on the positioning of the other groupings. This first one here, number 1, is now completely buried, and this one here, number 2, is completely covered in with modern stone blocks. And the first group of samples were taken from pit number 3 right here, which I have discussed in previous videos, and we'll put in a clip so you can see this area and what it looks like in person. And this is the area here on the eastern side of the central pyramid, south side of the temple, just near the exterior wall. And here is the first sample location, an image of the material, and a close-up, processed and microscope image described as a strongly ferruginous gypsum quartz sand with dark inclusions, most likely hematite. And there is no macro analysis on this one, but it is mostly iron oxide just like all the rest, and this one has a notable amount of barium. As you can see here with this particle of barite, 69% barium. Here we have some particles of manganese oxide, 26.52% manganese. More barite here with 48% barium. A strontium crystal here, 44% strontium. And the next sample location here. An image of the material and a close-up. And the macro element analysis here, 40% iron, 11% chlorine, 10% manganese, 6% sodium, 0.8% barium, and 0.6% silicon. And these macro numbers, once again, do not have any carbon or oxygen listed. Trace elements here, which we will take a look at comparing the differences in these samples at the end. And the SEM scans here, showing some celestine, strontium sulfate, 38% strontium and 14% sulfur. More barite here, 41% barium. Next up, the next sample location spot here, and they note that the sample was taken from the darker part in the center here. An image of the material and some close-ups here. No macro element composition, but the trace elements are listed here, and this sample is mostly iron just like all of the rest. And now, some very interesting electron microscopy here, with a 39% iron sample with almost 10% platinum, which is described here as the impression is that the sample is somewhere rubbed on the platinum material. Platinum forms very small and thin flakes, which are located strictly on the backbone of one of these sample particles. Not found in other samples, the analysis is very dirty, and the matrix material is clearly mixed in. So my question is, where the hell are these platinum flakes coming from? And another microparticle of platinum here at 10.56% platinum. And here, a fragment of chromium, 86% chromium. Very, very unusual indeed, and we will see more of this coming up soon. Next up, the next sample location here, an image of the material, and close-up here. The macro analysis, 43.7% iron, And we have here microparticles of iron oxide, more celestine, strontium sulfate, and next up, a very interesting iron oxide vein that is described here as the object is very reminiscent of a quote-unquote pipe. Below are photos of its continuation, in some places protruding from the sand toward the pyramid. And I will try my best to find this specific deposit the next time I'm on the Giza Plateau, because I really want to see this thing in person. And as mentioned, when discussing the iron oxide deposits that I discovered on the upper container housing on the second level of the Osiris shaft, those deposits look like bars of iron running across the top of the chamber. And these also have a very unusual, perhaps man-made appearance. But also keep in mind that they call these deposits veins for a reason, and this is how they are naturally formed. So I need to see this in person before I can comment any further on the possibility of these deposits being the remnants of an ancient metal pipe system. However, I am certainly open to that interpretation. And a very nice picture of the sample here. Close-up of the material. Macro analysis here, which we see 27.5% iron, 26.7% chlorine, and 27.4% salt. And here we have a crystalline intergrowth of barite and celestine. And next up, the next sample location here. Another picture here. An image of the material. And a close-up with a macro element composition of 49.3% iron. And here is a very interesting and very pure particle of ruthenium, 67.98% ruthenium, which, as they explain here, if not an impurity or some sort of modern contamination, this metal is inert and could have remained in this state since the time of the pyramids. A very inexplicable find to discover ruthenium in these samples. Another piece of celestine here, that strontium sulfate, and some pictures of the next sample location here, which is rut or pit number 4. The sample location here, an image of the material, a microscope close-up, and the macro element composition with 52.9% iron. Here we have another particle of barite, 35% barium. Next up, another sample location here, an image of the material, and a close-up. No macro analysis was provided for this location, but again, mostly iron, just like all the rest. Another sample location here, an image of the material, and a close-up. No macro analysis on this one, and nothing new in terms of the scanning electron microscopy. Same thing here, another sample location at pit number 5, the location here, an image of the material here, close up, and the macro analysis at 52.4% iron. Next up, the SEM scans showing some iron oxide, and the next location here, an image of the material, which looks quite different than the previous ones, as you will see reflected in the chemical analysis. A close-up here showing a little gypsum crystal, more crystalline material within the microscopic fragments here. And we have the sample coming in with a macro analysis at 52.4% iron. On the scanning electron microscope, we see more celestine, the strontium sulfate. This is a gypsum crystal here. Some more crystalline strontium sulfate. Another crystal of strontium sulfate here, that celestine mineral. And this is a crystal of gypsum. And on to the next sample location here. A beautiful image of the material. And a close-up here. No macro analysis was provided on this one, but the trace elements are listed here. And look at what we have here in the scanning electron microscopy scans. A particle of silver with an admixture of gold or electrum, described here as, judging by the shape of the discharge, lumpy with dendritic edges, a grain of natural origin, or recrystallized as a result of the long stay in the soil. So most likely this is a natural piece of electrum, a mixture of gold and silver, but still very interesting considering that it has been suggested that the Great Pyramid was capped with electrum. But I highly disagree with that conclusion, as I believe the Great Pyramid was intentionally left without a capstone, which I will be discussing in a future episode. Next sample location here, an image of the material, and a close-up. Macro analysis here shows that this one is mostly calcium, 36.8% calcium and only 11.3% iron. Trace elements listed here. Another crystal of celestine here, 42% strontium. And this very unusual flake is almost pure chromium, 85.89% chromium, a very, very rare and unusual find indeed. This is another small flake of chromium, with more of the background matrix included. Here is another small flake of chromium, 71% chromium. And yet another one, this one at 69% chromium. So in this sample, there are tons of microscopic chromium flakes. Where did these chromium flakes come from? That is still to be determined. Next up, sample location here, an image of the material, close-up, and macro analysis showing 52.4% iron. Nothing new on the scanning electron microscopy. Next location here, a close-up of the material, microscope close-up, and another macro analysis showing 52.4% iron. And here is a very interesting microparticle of gold, 62.48% gold and 9.12% silver with 1.72% iron. So this is almost pure gold, described as having a natural composition, not reminiscent of modern industrial alloys, and found at the bottom of the pit, which is natural for heavy gold deposits. Still another very interesting find in these samples. Here, another flake of almost pure chromium, 93.44% chromium, described here as a scale that has broken off a chrome-plated product. Where are these chrome-plated products coming from? Is this modern or is this ancient? Once again, still to be determined, but very, very interesting. And here is another piece of celestine, that's strontium sulfate. But what I want to know is what the hell is this piece right here? This is definitely metallic and has a very, very unusual shape. So I wish they had used this scanning electron microscope and scooted over just a little bit further to get the analysis of whatever the hell this is right here. And next up, this is some dendritic silver, a microparticle with 53.83% silver, so another very interesting sample at this particular location. And the last one, pit number 6, the location here, an image of the sample location, picture of the material, close up here, and macro element analysis showing 50% calcium, 4% iron, 0.4% silicon. And down here we have some celestine and some barium. So now that you have seen the chemical analysis of all of these samples, here is a clip from my 2022 research expedition showing these areas near the Central Pyramid of Giza. All right, and we're back here on the southern side of the Eastern Temple, and Yusuf just pulled up this big ass chunk. Oh man, that's heavy.
What do you call it?
Iron oxide.
Heavy metal.
Heavy metals, yeah. I mean, this might as well be a block of iron. And everything that you could see here, all of this material, this dark brown, reddish looking material here, it's another huge piece. And it all the way just covering this area.
All underneath us here.
And then I noticed last time we were here that this deposit leads down into this rut. And this entire rut is filled with iron oxide.
I have seen that stream far from here. You see this mound over there behind the cemetery? This high mound over there?
Let's see.
Actually,
oh yeah, yeah.
It comes all the way also. It's coming that direction almost. From here until the inside, we have seen it at the inside of the pyramid. Now we know where he saves his stash. كتير كده حبيبي الله يعزك يا شيخ ماشي حبيبي. He wants to give you an extra one.
I will take it. Thank you. شكرا شكرا.
ربنا يجبر بخاطرنا.
Thank you.
خد بقى الفارغ.
Man, hopefully you can see, because honestly, looking into this viewfinder at the moment, I can't see a damn thing. So hopefully this is coming through.
It will be, it will be.
But you can see all of this is that black, reddish brown deposits of iron oxide all through this rut.
You can see it here too.
Here's one. It's all over the place.
Actually, the entire ground.
It's a part of the bedrock.
It is.
And we've found this at every single site that we've visited in Egypt. Just massive deposits of iron oxide.
And this is a piece of petrified wood.
So petrified wood has always been incredibly fascinating to me. Again, you may have heard that when Yusuf dropped this thing on the sand, sounds like a piece of metal. But again, this is an ancient piece of wood. Kind of wish I could pack this up in my suitcase and take it home, but
I'll save it for the next journey.
I guarantee you I would be over the weight limit.
If you want, I can let one of the camels drop it at the shop. Yeah, no problem. So,
and as we walk around here, I just want to show you this. This is probably the largest area where this stuff is exposed.
yeah, definitely.
And as you can see here, this is the sand color.
Look at this one.
And look
brother.
how brown it gets over here. Here's another piece.
This is the dolorite pounders, the one they found at the Aswanian quarry.
Right.
And they claim that it lifted the scoops. That doesn't make any sense. This is obviously was used by the recyclers who left totally a different type of surface using these pounders.
And this is that huge deposit of iron oxide that runs. So this vein runs from
Hello, tourists.
the southern side into the core of the pyramid itself. And other researchers have proposed that perhaps there was an ancient iron mine on the Giza Plateau. Look at this. That's just a spectacular color. And they have samples of this material in the Egyptian Museum, which clearly the Ministry of Antiquities knows that there are deposits of iron oxide out here.
Look, Jeffrey, I was here with a friend one day and I found a lot of smoke coming out of this hole right here. So there used to be a small tunnel. As you can see, this part is descending where we are heading now.
Yep.
And as you can see clearly, what, look,
Yep, there's one.
The deposits of iron. And here, exactly where this cement, modern cement, is
patched up the hole. Yeah.
There used to be a tunnel. And I saw that smoke coming in the middle of the day of that tunnel. I didn't know who was responsible. There is nobody around, and how can be fire down there, and why? All this I didn't know. I came after 1 week, and then it was sealed with the blocks of stones and things like that. After many years, I was sharing this with some of my friends, like Enigmas of the Ancient World or other friends, and I saw this gentleman from the Ancient Architect YouTube channel was mentioning something that I also didn't know about before. He said that he has information that there used to be iron mining happening right here, and I wouldn't be surprised with all the mineral that we see around us. Of course, it appears sometimes to look like melted for some reason, of course, and again, Dr. Robert Chuck has his own opinion about this, while also our geologist teacher Susan Moore has another opinion. I believe all the geologists need to get together and give us a final result once and for all.
So my actual brother, if you're listening, watching this video, we need to get your ass to Egypt.
He's a geologist, right?
Yes, yes.
Okay.
All right, now on to the comparison of the trace elements and rare earth metals in these samples. And first, you can see here a total sum of the elements in each sample, with one sample location in particular having significantly higher concentration at almost 8,000 grams per ton, where all the rest of the samples were around 1,000 grams per ton. And that particular sample was taken from pit number 3 right here, sample location number 2 right here, and this is what the area and material looks like at that particular location. Next up, a comparison of the rare earth elements in each pit, looking here at pit number 3, at the 6 different samples that were taken from that pit, compared to the control, which you can see down here at the bottom, and they are comparing the concentrations of lanthanum, cerium, praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lucium. And sample number 4, which you can see here, from pit number 3, had the highest concentration of all of these elements. Next up, a comparison of the same elements from pit number 4 as compared to the control sample here, which you can see down at the bottom. Next up, pit number 5, and this particular sample here, which is sample number 1 from pit number 5, showing very elevated levels of these rare earth elements compared to all the rest. And pit number 6 here, which is marked in brown, compared to the control sample here in blue down at the bottom. And remember, this control sample was taken from almost 1 kilometer away from the rest of the samples that were taken adjacent to the central pyramid. And this is absolutely fascinating, groundbreaking research that I am revealing to you here today. But this is just the tip of the iceberg, and I will have my full assessment of this analysis coming up in part 2. But for now, also remember that these remarkable deposits of iron oxide and all of the microparticles that they contain are not only found outside of the central pyramid, but also inside the core of the structure. As you can see here, in this area within the core of the central pyramid, discovered by my friend and guide Yusuf Awian, and here within the primary reaction chamber of the central pyramid that I personally discovered last year. And here are some clips so that you can see these amazing new details from inside the central pyramid for yourself. All right, ladies and gentlemen, here we are inside the central pyramid of Giza. And we are at the convergence of the upper inlet shaft and the lower inlet shaft. So from the outside of this structure, there are two openings that would have led from the reservoir, delivering water into the internal system. And what Yusuf is looking at here is the deposit of iron oxide that we discovered in the core of the structure. So this,
Leave the flashlight.
yeah. So this is your upper inlet, and there's actually a space between this block and the one behind it. There's an opening, and if you look,
Get closer to where I'm looking.
see if we can get a good angle. Oh, perfect. That's the money shot. So there it is, ladies and gentlemen. The first video documentation of the iron oxide deposits located in the core of the central pyramid. Stay tuned for more.
It's crossing the room from this corner into the other corner.
Yep. So you see here what we're looking at, this patch?
Yeah.
Goes all the way down here. And this has been covered with modern concrete. And this is a stream of iron oxide that once ran all the way into the chamber and towards, and it dipped down here. Up there's the patch going up the wall. And this is a new discovery. I just noticed this. And I pointed out to Yusuf, and he's like, oh, that's modern concrete. I was like, no, there's iron in there.
But the modern concrete is over a layer.
Yeah. Yeah, and you can see it. There's another good spot on the wall. It's iron oxide.
Right here.
Yep. So this is very similar to what we just saw down in the Osiris shaft, where they
Putting
were
a layer on top of the ancient layer.
and they were tapping in to these iron oxide deposits in order to excavate these chambers. And you can see it runs all the way up and back into
Big chunk of iron.
like a bar of iron in the wall right there. All right, everyone, that is it for today's video. This was episode 75, a chemical analysis of the Giza Plateau iron oxide deposits, part 1. I really hope you enjoyed today's video, and in the next episode in the series, a very special exclusive announcement from yours truly. I apologize for keeping you all in suspense, but trust me, it will be worth the wait. So if you haven't already, now is the time to subscribe to the Land of Chem here on YouTube and click that little notification button because you do not want to miss what I have coming up here on the channel very soon. If you want to help support, just go to thelandofchem.com. You can pick up a limited first edition print copy of the book, grab yourself some merch. Either way, all the orders mean the world to me. Thank you all so much for the support. If you want to follow me on Instagram, my handle is @thelandofchem. Ladies and gentlemen, it is about to get crazy exciting here on the Land of Chem. I think that is it for today's video, so I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.